Hello guys. So we're going to start a new machine learning algorithm which is called as principal component analysis, and we also call it as PCA, and we also say it as dimensionality reduction. Now before we go ahead and understand what exactly is PCA, first of all we need to understand why should we use PCA or dimensionality reduction. So for this we really need to understand about a topic which is called as curse of dimensionality. Okay, so curse of dimensionality. And in order to make you understand this specific topic, let me take some examples over here. Let's say I have various models. Okay, so let's say this is my machine learning model M1, this is my machine learning model M2, this is my machine learning model M3, this is my machine learning model M4, and I still have some more machine learning models, so be patient. Okay, M5, and this is my machine learning model M6. Okay, so let's consider I have this many machine learning models. Now let's say that I have a data set, and in this specific data set I have somewhere around 500 features. Okay, and whenever we say about dimensionality, this basically means we are talking about something called as dimensions. And whenever I say dimensions, this is nothing but this is features. Okay, so let's say this data set that I specifically have is to basically determine or find out the price of the house. Price of the house. So some of the features that I may have in this data set is like house size, right? Let's say number of bedrooms, or it may be number of bathrooms, or it may be, I may also have features like number of bathrooms, right? I may have this many kind of lot of features. Okay. Now, obviously, to basically find out the price of the house, what is the most important thing? Probably you need to know the house size, you need to know the room size, you need to know the number of bedrooms, you need to know how many number of washrooms, right? Let's say for the model M1, I have provided around the most three important features to train out of this entire 500 features. Okay. Let's say after that, for the M2 model, I provided somewhere around 6 features for training the model. Okay. Similarly, for the model 3, I have provided around 9 features, let's say for training the model M3, right? And after that, for the M4, let's say I have provided 50 features. Okay. Or let me just not make it as 50 right now. Let's say that, okay, in this particular case, I have provided probably 15 features. Okay, so let's say over here I have provided 15 features, and here now I have increased the number of features. Here I have provided 50 features for training this particular model, and then probably here I have provided 100 features, and then here I have actually provided 500 complete features. Okay, now what will happen when I'm providing this many number of features for every model? Okay, now let's say this model M1, I will be getting some accuracy. Okay, and this accuracy is based on these three specific features, right? So here, let's say this is my accuracy 1. So here I am specifically getting accuracy 1, right? Now, after I train my model with these three features and probably train this particular model, I'm going to get accuracy 1. Now let's go to the next model where I have specifically used 6 features, and let's consider these 6 features all are very, very important for determining the price of the house. Then what may happen is that my accuracy 2 will still increase, right? When compared to accuracy 1. So here I can definitely say accuracy 2 will be greater than accuracy 1. Then let's say M3, again, when whichever features we actually provided, like this 15 features, are still more important when compared to the previous 6 feature. So I may get an accuracy 3, which may be more good at this point of time. Okay. Now let's say when I probably went to model 4, here now you will be able to see that I'm providing 50 features. Now, in these features, there may be a scenario that some of them may not be at all so much important, right? And some may have more importance, some may have very less importance, some may have no importance at all, right? So now, when we will try to find out the accuracy, here you'll be able to find out the accuracy will keep on decreasing when compared to the previous accuracy. Now, what will happen is that in this scenario, you will be seeing that this accuracy 3 will be greater than this accuracy 4. Okay. And I'll explain you why this specific thing will probably happen. So let's say this is my accuracy 4. And here you can see that the accuracy 4 has decreased when compared to accuracy 3. Then when I go to the next model where I'm specifically providing 100 features, here the accuracy will still decrease. And then when we go to the next model where I have specifically provided 500 features, and this may include all the features that I've provided in the data set, here you'll be able to see the accuracy 6 that you will be getting will still more decrease when compared to the previous accuracy. Now you may be thinking, right, why this thing is basically happening. This is the reason why we say curse of dimensionality. Now just imagine, guys, it's just like over here, in model M1, M2 and M3, when we were seeing that after training with, let's say in M3 model, we were training with 15 features, the accuracy was quite increasing over here. And we can consider that this all features were quite important for this particular model to perform well, you know. But when we went to accuracy 4, or when we went to probably this model 4, you know, here we have increased the number of features. Now this specific model need not require that many number of features to do the prediction. Over here, you can just say that the model is overfeeded, right? The model is overfeeded. So model should be given that many number of features through which the accuracy should keep on increasing. But here you can see that the accuracy is decreasing. Similarly, after this particular step, when we go to the next step, you know, here also you could see that as soon as I provided 100 features, and obviously in these features, there may be a situation that some of the features may not be at all useful, you know, but still it is, model is basically getting trained on that, and a lot of confusion actually happens within the model itself. Why? Because see, model is altogether inside, if you probably say, right, any machine learning algorithm, those are nothing but mathematical equations. Now, with respect to mathematical equations, you know, as you keep on feeding new and new features, it will try to learn those features also, even though it is not that important, right? So because of that, your model will get overfitted and it will definitely lead to a lot of confusion. And based on that, as the number of features gets increased, your model will start performing, like it'll stop performing well, you know. And from that point of time, your model performance will also degrade. Now here, your second point is that your model performance will also degrade. Why? Because as the number of features are increasing, just imagine the number of dimensions are increasing, your model performance will degrade because now the mathematical calculation will happen for that many number of dimensions. So because of that, the model performance will also degrade. Okay. Let me give you a very simple example. Let's say you are a human being. Okay. Let's say there is a person. I'll just consider there's a person over here. Let's say. And suppose I will just ask this person, okay, what is the cost of a house in this specific location? Okay, in location A, what is the cost of the house? Okay, then the person will probably understand some of the features. Okay, which location this is? Okay, and let's say he does not have any other location, any other features. So this location may be my feature 1. Now here he may guess that, okay, your house may cost between 450K to 500K. Okay. Now I say that, no, I specifically want a 3 BHK apartment. Okay. Now I have got a new feature. Okay. Then he may say that, okay, fine. This was for an average. He just thought that, okay, this may be an average price for a 2 BHK apartment. Now when he says 3 BHK apartment, then he may say that, okay, now your price may be rising between 600 to 500 to 600K. Then he suddenly says that I need a house near a beach. Okay. Now this particular parameter is added. Now you know that what will happen, the person will start thinking and this price will keep on increasing. Okay. Then let's say after some point of time, the person demands increases. The other person who wants to buy the house, he says that I want a house near to a celebrity. Okay. Near to a celebrity house. So let's say now this particular feature is also added. Now here again, the price will keep on increasing like this. It will keep on increasing. Now suddenly the person says, now I also want something like in beside my house, there should be a lot of grocery shops. Now, this particular feature may not be that important to basically increase the price or not, but still we are adding this particular feature for training our model, right? Now, what will happen? You know, this may create an impact, but it will create a very less impact. Okay. Then suddenly you'll be saying that, okay, how many number of schools are there surrounding my house? then suddenly one more feature will keep on getting added. Now, as soon as we keep on adding this many multiple things, this person who is about to say the price, right, he will also get confused at one point of time, right? Because we are just overfeeding him with multiple features. Okay, I want this, I want that, I want this. So now the person will still get confused and he will not be able to tell you the proper price. That basically means the performance of this particular person, who's a domain expert in telling you the price range of the houses, will decrease, and he may also not be able to tell you the accurate result. And this is the same thing that is happening when we train our model with many features. That is where your curse of dimensionality comes into picture. Now the question rises, how do we prevent it? There are two different ways how to remove this curse of dimensionality. So two different ways to remove curse of dimensionality. One is feature selection. Now, what does feature selection will be saying? That we will try to take the most important features and then we'll try to train our model. That is what happens in the feature selection. The second technique which we are going to discuss in this series is something called as PCA. And I'll not just write PCA, I'll just say dimensionality reduction. And in this series, we are going to focus more on dimensionality reduction. And in dimensionality reduction, there are again many algorithms. We'll start with PCA, that is principal component analysis. Okay. So two ways to remove curse of dimensionality. One is through feature selection. In feature selection, what we do is that we try to take the important features and then we train our model. Whereas in the case of dimensionality reduction, what we do, and this process is basically called as feature extraction. Okay. Feature extraction. Now, feature extraction basically says that we'll try to derive a feature from a set of features, where we'll be capturing much essence of the previous feature. Let's say that I have features like F1, F2, F3, and this is my output. What we'll do is that we'll try to derive a feature like F1 and let's say we'll try to derive a new feature. This will be a D1 and D2 from out of these three features, and we'll use these features to basically find out our output. Okay. Then we'll try to see that how do we derive this particular feature and everything. In short, we are extracting this new information. So that is the reason we say this as feature extraction. Super important topic. Okay. So I hope you got an idea about what is curse of dimensionality. In brief, if I tell you that as we keep on increasing the number of features, those features at one point of time when we are training those models, my model will get confused because I have so many features to learn. And because of that, the performance of the model will basically degrade. And I have also given you an example with respect to a specific person, right? If you keep on adding features and if you ask this domain expert what may be the price, then he or she may also get confused with respect to this, right? So how do we prevent or remove curse of dimensionality? There's two techniques. One is feature selection and the other technique is something called as feature extraction. In feature extraction, we are going to learn about the first technique, which is called as dimensionality reduction. And in that, we are going to learn about this algorithm, which is called as PCA. Okay. In short, we will be extracting some features from out of the previous features. So this was my original feature. And out of this, we will be extracting some features like this. It may be in lesser dimensions. And obviously, remember, this will be in the lesser dimensions. And we'll try to capture the essence out of all these original features, the same essence of variance, I can also say. And then we'll try to derive this particular feature, which will be able to perform well when we are training our model. So yes, in the upcoming video, we are going to now deep dive into what is principal component analysis, and we're going to understand the geometric intuition. So thank you. I'll see you all in the next video.